Hi everyone, this is Miss Ramirez, and we are now in week 2 of our distant learning. And I'm hoping that everybody's doing okay, just kind of hanging in there and continuing to check in Google Classroom and working on the assignments. This week we're going to be looking at skeleton equations, so I thought I'd kind of just review some of the problems that will be on the hyperdoc that is assigned today on Monday. Keep in mind, just a kind of housekeeping, make sure that if you did not turn in the assignments from last week, you want to make sure you get those turned in. And you want to make sure that you have all of your Google slides for your presentation of your ingredient label project done and submitted through Google Classroom. That's due this week as well. So just 2 assignments and that I have posted for week 2, and of course your project that's due on Wednesday. Okay, so I just wanted to give you guys some just review the 4 problems as we move on along with chemical equations, talking about skeleton equations. And one of the main difference between skeleton equations and chemical equations is that the skeleton equations are not balanced. So we're just kind of taking all of those chemical names and chemical formulas and turning them into an equation where we have the names turned into formulas. We have the plus signs, we have the arrows before we start balancing equations. So I'm going to go ahead and I'm hoping that you guys can see my screen. And we're going to just look at the 4 problems that I assigned in the hyperdoc on skeleton equations. So we're going to start with the first one. So hopefully after you've watched the video and you've worked on the hyperdoc, you have a better understanding of how do we set these equations up. So number 1, it says that we have aluminum metal. And because a metal is sort of describing a solid, we are going to put the state of matter as a solid. So aluminum, we're going to put Al, that's the symbol of the metal. And then we're going to go ahead and, let me see, I'm going to go with the marker here. And we're going to put the S to represent the solid state. Okay, and then it says it reacts with, and keep in mind that react with, all we're trying to do with these word sentences is translating them into equations. So that's going to be a plus sign. And then it's going to react with iron 2 oxide. So in our understanding of, putting these chemical formulas together, we know that iron is going to be Fe, and then we have oxygen is O. Now we're not going to put a 2 next to oxygen because the only time we put that 2 next to oxygen is if it's an oxygen gas or just oxygen by itself. But it says iron 2 oxide. So we're going to look at our periodic table, and we notice that oxygen is right over here, and that's going to have a -2 charge or a 2 negative charge. So we know that all the time, oxygen is going to have a 2 negative charge. So I'm going to go back here and put that sign there. Now, iron 2, that Roman numeral again expresses the charge for these very metallic or transition metal elements. So that's going to be also telling us it's a 2 plus charge. So notice that iron has a 2 plus, oxygen has a 2 negative. Those cancel out, giving us the formula for iron 2 oxide, FeO. Okay. It says powder, so I'm assuming that is a solid state to produce. So what is going to be the next thing that we write? It's going to be the arrow, showing what is being produced from these 2 reactants. The solid aluminum metal is going to react with the iron 2 oxide to produce now a solid aluminum oxide. So aluminum, because it's bonding the oxide or the oxygen, we want to make sure that we address the charge. Now, we know from our periodic table that oxygen, again, is a 2 negative. And then we know that the aluminum, which is right here, will always have a plus 3 charge. Okay, so what we're going to do is we're going to put 3 plus, and then we're going to put 2 negative there. So that 3 plus, that 2 negative, they're not going to cancel out. So we're going to do the crisscross method. And that's going to turn into, okay, aluminum Al2O3. That's why last week we reviewed writing these chemical formulas. It's very important that as we move forward, we're able to do that. So then the word and is going to be represented by a plus sign. Okay, I started adding all these different colors, but that's okay. And we're not going to forget that this aluminum oxide is also going to be solid. And the solid and all of these kind of descriptions of the state of matter of that particular chemical compound is going to be just kind of a subscript, just kind of laying on the side. And our iron metal, basically a solid as well. And again, we're not going to add a 2 next to the iron just because it's not one of those 7 diatomic elements, okay? Even though it says iron metal, iron is not going to carry that 2. So we're done with number 1. And so we're going to go ahead and start with the next one. And let's go with number 2. Okay. All right, number 2 says ammonia gas. And so they give us the chemical formula for ammonia. So that's going to be okay. And it's a gas, so we want to make sure we don't forget to write those. And then plus is going to be a plus sign. Oxygen gas. Now notice again that it does say oxygen gas. So we know that oxygen gas is one of those 7 diatomic elements. So we want to include that subscript 2. So I'm just going to highlight these, box those, and then oxygen, hydrogen as well. Okay. So if it's by itself, we want to make sure that we note that particular diatomic element. It says oxygen gas. We're going to put a little 2, and we're going to represent the matter of this oxygen gas. And it says it yields, so we're going to put our arrow. Nitrogen monoxide. So notice monoxide is there, which means that's a prefix, which should indicate that that is a covalent compound. So we're going to write the formula as N to represent nitrogen, and mono is 1. So we're just going to put the O. There's no need to put the 1. Okay, we ignore it. It says not needed there. And it's a gas, so we're going to put that to represent that state of matter. Plus, so that's in there. Water vapor. We know water is H2O, so we go ahead and put that here. And we're going to put that as well. Okay, very good. Alrighty, now we're moving on along to number 3. And for number 3, now notice it says calcium hydroxide. Hydroxide is going to be a polyatomic ion with a -1 charge. So that's going to be OH, 1 negative. Now, if you notice where calcium is at on the periodic table, notice that it has a +2 charge. It's in group 2, so that's a 2+ charge there. So that's a 2+. Okay. So that's going to be, okay, so a 2, if I can write, let me erase this because it's getting really hard to read there. But it's going to be a 2, let's see, let's write this here. A 2 plus, and oxygen is a OH 1 negative. So that's going to be something where we're going to have to crisscross and don't cancel. So that's going to be easy. We're going to do hydroxide, so we ignore that. And then we have OH. And if we're bringing down the 2 calcium, we got to hug that hydroxide and put a 2 there. Okay, so this is the chemical formula for the calcium hydroxide. And so now we are going to move on, and the word and. Now it says, oh, before we move on, it says solution. From the notes before, anything that is of solution, right here, there, is basically something that's dissolved in water. So it's not going to be S because S is the abbreviation for solid. So we're going to write AQ, which means as AQ. And then we have the word and. So that's where we're going to put the plus sign. Okay. And now we look at the next part, which is carbon dioxide. So di is a prefix that's used only for covalent molecules. So we're going to write it again as it states. Carbon will go as C, and then di means 2. So we're going to put O to represent the oxygen, and then 2. It's gas. Okay, bear with me here. I'm going to put a G in parentheses. Not the best visual here. Okay, now it says it yields, so it's going to represent the arrow. And solid calcium carbonate. That's why it's really important to kind of have an understanding when you're using a polyatomic ion and when you are not. So looking at calcium carbonate, and let me go over here and let me go new drawing. So I'm going to just use my pad here so we can kind of look at what that means. So calcium is going to be, okay, and again, looking at the periodic table, calcium belongs to group 2, so it has a 2 plus charge. So we're going to put that. So what we're trying to do here is just kind of put that formula together for the calcium carbonate. Now, carbonate, if you look on the periodic, not the periodic table, but the polyatomic ion list, you'll notice that carbonate looks like CO3 with a 2 negative charge. Okay, now notice that that's a 2 plus, 2 negative. Those will cancel, no need to crisscross. So basically that becomes CaCO3. Okay, and that's what we're going to write in our skeleton equation. We're going to put down the CaCO3. Okay, seems like my stylus doesn't work very well on this platform right now. And that's going to be a solid. And so we want to write, okay, and the word and is what shows up next, as you see here. And then it says liquid water. So again, we'll take the H2O. And we now, instead of putting it as gas, it's liquid water. We are going to put the state liquid will be L in parentheses. And that should be closer to the O. I'm just running out of space a little bit. So, but yours should be able to show all of that. And because you are working on the hyperdoc and it's asking you to type them in, you should be able to type these in. I'm just writing them out because that way it's easy for me to show you the steps. But I want you guys to practice typing the answers. If you want to work on them on a sheet of paper and then give me the final answer on the hyperdoc, then that would be great. All right, let's take a look at the last one, aqueous iron 3 chloride. So let's take a look at, notice, iron 3 chloride. I'm going to go ahead and move this out here and do a new one here. So iron 3 chloride. So obviously iron is going to be Fe, and it says a Roman numeral 3. So that is going to represent the charge of that transition metal. And that's what we're going to write right above it as a superscript. Then it says chloride. Now we know on the periodic table that chlorine is right over here. And this last group always has a -1 charge. So we are going to put chlorine with a 1 negative charge. Now notice, this one's a 3 plus, that's a 1 negative. So we are going to have to crisscross. So we crisscross, and that becomes FeCl3. And that is going to be the chemical formula for that first part, iron 3 chloride. So I'm going to try to write this in here. Now notice it says aqueous, so that's a given that we're going to abbreviate it as a Q. And that again is a solution, something that's been dissolved in water. Then it says and, so we're going to put the plus sign, and then sodium carbonate. Now sodium carbonate again is going to have a polyatomic ion. And again, the only way to know these is to basically look at your sheet or just memorize these polyatomic ions along. So we're going to do sodium carbonate. So sodium is an easy one. We know sodium belongs to group 1. So that's going to be a +1 charge, or 1 plus. So we'll go ahead and put that there. And now carbonate is CO3, 2 negative. Now look at the charges, because that's what drives if we're going to have to crisscross or not. It's the charges up here again. It's not the 3 down here. It's the charges up there that we want to be able to cancel out for them to form the bond. So we have to crisscross in this particular problem. So we're going to go Na. That's going to bring down that 2, and then that's CO3. Okay, so that's sodium carbonate. So that's what we need to write. That's the next step here. So sodium okay. And it says solution. So again, a solution is AQ. It's not S, because S is a solid. It represents the abbreviation form of a solid. Okay, and it says it yields. So that's where our plus sign comes into play. And then it says aqueous sodium chloride. Now you know sodium chloride, so I'm not going to go ahead and write that out. So I'm going to just put the arrow here, because I got excited with all of the plus signs there. Okay, so we're going to go Na, Cl, and that's also aqueous. Okay, good. Now we're going to move that up there. And now we're going to put a plus sign there. And it says, and a precipitate of iron 3 carbonate. So let me go over here. I'm going to try to work that one out. So iron 3 carbonate. So iron 3. So we're going to take that iron 3 and we're going to put that Roman numeral 3 as its charge. And then carbonate is, again, CO3. Again, these charges do not cancel out. So we're going to crisscross. And we're going to bring the iron down. So 2, CO3. And that's going to be 3. So we must put parentheses between the two. And then that is, we're going to write over here. So that's going to be the chemical formula. So we're going to put Fe, and then that's going to be 2, parentheses, CO3, parentheses, 3. Now, it is a precipitate. So, and a precipitate is going to actually represent a solid. So, precipitate is still a solid because it's still mushy, something that can be seen the bottom of the reaction when you take these two liquids and they react. Precipitate is considered a solid. So, we'll put that S there. Okay. And I think that's it. So I hope this helps out as you guys work on these skeleton equations as we move forward into then how do we balance these equations. So the skeleton equation is kind of the step prior into starting to balance equations out. Okay? All right, have a good day. You guys take care. And I'm going to close this here.